In this lesson, I'm having students graph quadratic functions in intercept form or factored form. Students have previously identified the x-intercepts from factored form using zero product property in the polynomial unit, so they know to find the x-intercepts. We're going to find those first. And it's different than standard form and vertex form, because on those forms, on both of those, we found the vertex first. But in intercept form, you find the x-intercepts first. So we're going to set each one of the factors equal to 0. And then just solve for x. Add 1 to both sides. X would be equal to 1. Or subtract 3 from both sides. X is going to be equal to negative 3. So that's going to be your x-intercepts on the x-axis at 1 and at negative 3. And then we talk about, well, how do we know where the vertex is? Where would the x-coordinate of the vertex be? Well, we know the parabola is symmetric, so we know the x-coordinate is exactly between the two x-intercepts. So on this one, you can easily count and see that it's at negative 1. It's not going to be a point because we still have to find the y value of that point, but I'm going to make a little mark right there and erase it in a minute. So we know it's at negative 1. So if x equals negative 1, if we substitute negative 1 back into the given function, and you had negative 1 minus 1 times negative 1 plus 3, that's going to be negative 2 times 2, which is negative 4, and the vertex is going to be at negative 1, negative 4. So negative 1, negative 4. And that's the only 3 points that students need to be able to graph the function in intercept form and then draw it as a U-shape, not V-shaped, because V-shaped would absolutely be the absolute value function.